This is geometry, section 3.8, parallel and perpendicular lines in the coordinate plane. So, parallel lines. How do we tell if two lines are parallel? Lines are parallel if and only if they have the same slope. So, looking at all of these lines, we're going to decide which ones are parallel. This line is in slope-intercept form. It's got a slope of 3. Same thing with this line. Slope-intercept form, it's got a slope of -3. This line, slope of 2. This line, careful here, this is a 7 plus 3x. The slope is the number that goes with the x. So this is a 3. This line, and this line all are x equals some number. All of those lines are actually a vertical line. For example, x equals 7 is a line where the x-coordinate is always 7. It's a vertical line, which is true for all three of these. So the slope for a vertical line we talked about in the last section is undefined. Undefined. This one, slope is 0. This one, again, be careful, this says 1/2 minus 3x. So the slope is this -3. This one is y equals, so this is the opposite of what the vertical line was. This is now y equals 3, a line where the y-coordinate always equals 3, which is a horizontal line. So the slope of a horizontal line is 0. So this line right here, slope of 0, goes with this line right here, which has a slope of 0. So J is parallel to F. These two slashes right here mean parallel, just like we've talked about perpendicular is the upside down T. These two slashes right here means parallel. So J is parallel to F. We've also got A has a slope of 3. D also has a slope of 3. So A is parallel to D. Then, so A is gone, D is gone. So B has a slope of -3. H also has a slope of -3. So B is parallel to H. C has a slope of 2. Nothing else has a slope of 2, so that's not parallel to anything. And then we've got 3 undefined slopes. So E is parallel to I, which is parallel to G. All 3 of those are parallel. Are the lines y equals 2/3 x plus 5 and -12x plus 18y equals 108 parallel? Well, we can easily tell the slope of this line right here because this is in slope-intercept form. So the slope of this line is 2/3. We now have to decide if the slope of this line is also 2/3. So to do that, we have to put this in slope-intercept form, which means we have to solve for y. So I need to add 12x to both sides. I need to move this over to the other side to start getting the y by itself. So I've got 18y equals 12x plus 108. I need to divide by 18 to get the y by itself. So then I have y equals 12 over 18x. 12 over 18 would reduce, because 6 goes into both of those, so that would reduce to 2 over 3x. And then I've got 108 divided by 18. I don't really care what number that is, because all I need from here is my slope, which is 2/3. This slope is 2/3, so yes, these lines are parallel because they have the same slope. Next example. Graph a line that is parallel to the given line and passes through point R. So this line, first of all, we have to decide what our slope is so that this line that we're going to draw can have the same slope. So from this point to this point, I'm counting a rise of 1, 2, 3, and a run of 1, 2, 3, 4. So my slope is going to be 3 over 4. I could also count that as down 1, 2, 3, and to the left 1, 2, 3, 4. Because if I try to graph this line with point R, if I go up 3 and over 4, that's going to take me off the page. So we'll go down 1, 2, 3, and to the left 1, 2, 3, 4. Again, down 1, 2, 3, over 1, 2, 3, 4. So if we graph that line, we cannot tell exactly where our y-intercept is. It looks like it's a little bit less than 3. We can't tell exactly where it is. So we can't answer this question yet. We can write an equation of the line. We can't write the slope-intercept equation because, as we just said, we don't know what the y-intercept is exactly. But we learned in the last section we can write a point-slope equation. So let's use this point right here that we came up with. We've got the point 3, 5. So we'll use those coordinates in the point-slope equation of our line. Point slope says take y minus the y coordinate of your point, which is 5. We said our slope was 3 over 4, so 3 over 4 times x minus the x coordinate of your point, which is 3. So, to find the y-intercept, we need to distribute this 3/4 and solve this equation for y to write it in slope-intercept form. So if we do that, if we distribute the 3/4, we've got 3/4 x minus 3 times 3 is 9, and then 9 over 4, because it's 3/4 times negative 3. So minus 9 over 4 equals y minus 5. We still have to get the y by itself, so we have to add 5. So I have 3/4 x minus 9/4 plus 5. Well, this is going to give me y by itself. So these two numbers, when I combine them, that's going to give me my y-intercept. I don't really care about any of this anymore. All I care about is these two numbers, what that gives me when I add them together. So negative 9 over 4 plus 5. To add them together, I need a common denominator. 5 right now has a denominator of 1. So I need to multiply this by 4 over 4 so that I get a common denominator of 4. I've got negative 9 over 4 plus 5 times 4 is 20 over 1 times 4 is 4. So now I have negative 9 plus 20 over 4. Negative 9 plus 20 gives me a positive 11 over 4. If I change that to a decimal, that gives me 2.75, which looks like it could be pretty accurate on my graph. 2 3/4, 2.75, looks like my intercept is probably 2.75, so we know we did this right. More examples. Write the equation of the line that is parallel to y equals negative 4x plus 11 and has a y-intercept of negative 56. Well, my slope has to be the same, so m has to be negative 4. Y-intercept, it tells me, is negative 56. So if I write an equation, y equals mx plus b, m is negative 4, b is negative 56. So y equals negative 4x minus 56. Parallel to 2/3 x minus 9, y-intercept of 13. So slope is 2/3, b, or y-intercept is 13. Again, 2/3 x plus 13, that's my equation. Parallel to y equals 1/2 x minus 10 and passes through 24, 40. So now we don't know the y-intercept, but we do have a point and the slope. So we're going to have to write a point-slope form of the equation. So I have y minus my y-coordinate, which is 40, equals 1/2 times x minus my x-coordinate, which is 24. I still need to find the y-intercept. So like we did before, we have to solve this equation for y. First we have to distribute. So 1/2 x, 1/2 of 24 is 12. So this becomes a minus 12. Then I have to add 40 to both sides. So y equals 1/2 x, negative 12 plus 40 is 28. So y-intercept b is 28, slope is 1/2, y equals 1/2 x plus 28. Same thing for this one. I've got a point, and I know my slope needs to be 3, because that's the slope of this line right here, and I need them to be parallel. So again, y minus my y-coordinate, 32, equals my slope of 3 times x minus my x-coordinate, which is 4. This is a little bit easier because I don't have fractions, so y minus 32 equals 3x. 3 times negative 4 is negative 12. Add the 32 to both sides. Y equals 3x. Negative 12 plus 32 is positive 20. So y equals 3x plus 20. That would be my equation. B, my y-intercept, is 20. And m, my slope, is 3.